Hey everyone, in this AP Chem series video, we're going to take a look at how to interpret a mass spectrum. So remember from the last video that if you wanted to do mass spectrometry, first you'd have to get a mass spectrometer. Then you'd have to get some atoms to inject into the mass spectrometer. The spectrometer will separate those atoms based on their different masses and spit out a graph that looks like this. We call this graph a mass spectrum, and in this video we're going to start to learn how to interpret that mass spectrum. So let's say I took a sample of boron atoms and had them analyzed by a mass spectrometer, producing the mass spectrum shown below. The first thing you'll notice on this and any other mass spectrum is the presence of these vertical lines. We generally will refer to these vertical lines as peaks. And each of those peaks simply corresponds to particles of different mass that got passed through and separated by the mass spectrometer. So right off the bat with these two separate peaks, I know some of my boron atoms had this certain mass and other boron atoms had a different mass. That explains what you'll see down here on this horizontal axis. It's going to have the units mass per charge of each particle tested. Now the mass part makes sense. The per charge part or divided by charge part is a little more confusing. Luckily, most of the time the charges of the particles are simply +1. So that means whatever the mass is, you're just dividing it by 1 anyway. So the value that's actually plotted on the axis is simply just the mass. Here for my boron atoms, the peaks can be found plotted at 10 and 11. That means some of the borons had a mass of 10, others had a mass of 11, which really means that my boron atoms come in two different isotopes, boron 10 and boron 11. The last element of the spectrum that needs some analyzing has to do with the heights of the peaks. You can see this one at 10 is much taller, while the 11 peak is much shorter. The peak height simply corresponds with the particle quantity. The taller it is, the more abundant that particle was. So right away I can see that my boron 10 isotope must be more abundant, or there was more of those in the sample than boron 11. This mass spectrum in particular on the vertical axis graphs something called percent abundance. That means not only do I know boron 10 is taller and more abundant, I can follow the height of that peak over to the vertical axis and look up that those boron 10s made up 81.3% of all the atoms in the sample. The boron 11s made up the other 18.7%. So let's summarize my final analysis after interpreting this mass spectrum. I know that boron comes in two isotopes, boron 10 and boron 11. I also know that boron 10 makes up the majority, 81.3% of all the boron atoms, whereas the boron 11 is slightly less common. Make sure to take a moment and write down some of the key ideas related to interpreting a mass spectrum. And that wraps it up for this video. Thanks a lot for watching. Here's a brief summary.